Okay, I want to end up this review of multiple aggression coming back to interactions. And we really want to make sure that we are on the same page when it comes to interactions, that all of you have a good idea of what an interaction is. Because where we're moving next week is when we have interactions, what do those actually mean theoretically? Because a lot of times when we have an interaction in multiple regression, it's not just that we're creating a term because we're curious that there may be an interaction between variables, or creating a term because our residual plots told us. A lot of times we have a causal or a model driven reason to expect an interaction that is going to require us to peel the onion more and find out exactly what kind of interaction do we have. So to begin with, we want to just review what we already know about interactions. So the interaction is the relationship of one predictor, and the outcome depends on the value of another predictor. So there's an interaction between two or more predictors. The way we look at them in a multiple regression is we compute the interaction term by simply multiplying the two predictors together. Again, these variables can be continuous or categorical. However, if they're categorical, they do need to be dichotomous. So, for example, we could have hours of sleep by drinks per day by taking sleeping pills, yes or no. So we have both drinks, we have the dichotomous sleeping pills, and then we have drinks by sleeping pills. Is there an additive or more of an effect than with drinking and pills than pills alone or drinking alone? So if the interaction is significant, that means that the second predictor moderates the relationship between the first predictor and y. So for example, taking sleeping pills moderates the relationship between the number of drinks per day and the hours of sleep. The first thing we can do is if that moderator is categorical. When it's a categorical moderator, it's fairly easy to figure out the relationship. We can just split the data set and look at pill users versus non-pill users. So we can run two separate regression analyses. We can run a regression analysis of sleeping pills on alcohol when they are non-pill users versus when they are. So for example, we might find that if sleeping pills are taken, drinks have a fairly strong impact on the actual outcome of sleep. When sleeping pills are not taken, drink has a fairly weak relationship with going to sleep. In other words, it's the combination, pills and drinks get you to sleep a lot quicker according to this particular set of data. And we can also then draw that basically if we're looking at no pills, the amount of drinking actually has almost a negative relationship. So when you're not taking pills, the hours of sleep goes down with the amount of alcohol. However, if you're taking sleeping pills and drinking, the amount of sleep goes way up as you drink. Now, we could also look at this as drinks per day. So the previous slide was simply looking at the ends of that relationship. This is looking a little bit more of how does that relationship occur. And we actually find effectively linear relationships here, but they're moving a little more curvilinear, that there's a certain drop-off depending on drinks per day. So if we start at 0 drinks, 5 drinks, we see a pretty big shift. A little smaller shift with 10, a little smaller shift with 15. And again, we actually start to see a leveling off or even an improvement depending on which condition you are, no sleeping pills or sleeping pills. So this is an example of a fairly easy to understand and fairly easy to think about interaction where the categorical moderator of sleeping pills changes the relationship between hours of sleep per night and drinking. Now, if we didn't have that interaction term, this would come back to those residual plots. This would probably create an issue where we would have evidence that we needed to create interaction. We'd probably find heteroscedasticity in our residual plots if we didn't include this interaction. Because sleeping pills do predict sleep, drinking does predict sleep, but it's the combination that creates a very different relationship. Basically a positive relationship on sleeping pills and a negative or maybe non-significant relationship without sleeping pills. If both the predictors are continuous, again, we have the first predictor moderating the relationship between the first predictor and y. So the number of sleeping pills taken per week. So now instead of sleeping pills or not, we're talking about the amount of sleeping pills. Moderates the relationship between the number of drinks per day and hours of sleep. Now in here we're going to have to just select one or two specific values for that moderator, that continuous moderator. Often what we'll do is we'll look at one standard deviation above the mean and one standard deviation below the mean to look to see how the relationship changes. So we're basically going to say we're going to look at the bottom third of sleeping pill use and what is the relationship between drinking and sleep there compared to the top third of the relation of the amount of sleeping pills took. What does the relationship between drinking and sleeping look like there? So again, we can run the regression equations and look for the differences. We can look at the differences between the overall prediction, but also what does it look like if we break out the differences. So for example, we might find that standard deviation below the mean is 4 pills per week. We look at the relationship of 4 pills per week on drinking. Then we look at the actual relationship between drinking and sleep if you're at the mean, and what if you're at the drinking and sleep one standard deviation below the mean. So for example, here we might find that as you take more and more pills, one standard deviation above the mean, the effect on sleep actually goes down. So that combination of a lot of drinking and a lot of pills results in a negative relationship, while if you're at the mean or below the mean of the amount of sleeping pills taken per week, you actually see a positive relationship between sleeping pills and drinking. So again, when you have an interaction, you again become a detective. You have to start asking, how does this actually, what is the interaction, and how can I quantify it, how can I explain it, and how can I visualize it? So again, these are not perfect linear lines, but we kind of get the idea that the mean of sleeping pill use, above the mean sleeping pill use, both positive relationships between sleeping pills, drinking, and sleep. However, either no relationship or a slight negative relationship if you're taking too many pills. So again, this is an example that when we divided them into simply pills or no pills, we found a different interaction than if we actually looked at the number of pills. So again, the type of variance we measure, the type of scale we're using, can also give us a better idea of what's really going on. And again, we just have the equations then